to go ahead, go over the homework. I'll do it. There's a couple things in here I know I have to talk about from last night's homework, and that's completely fine. I did it on purpose. And then we're going to go ahead and practice today. You'll have regular problems, and then we're going to talk about word problems that are arithmetic, geometric, sequence / series. That what we give you today, you'll actually be doing today and tomorrow. It'll just carry over because you will not get it finished in class today. I know that. So it's just going to be your assignment tomorrow as well. And then there's the homework from last night. So let me. Okay. And then we'll come back on Thursday. We'll take care of the homework, but we're also going to have a quick quiz on Thursday dealing with the basics of arithmetic and geometric sequences and series. Okay. Okie dokie. So there are the answers. You'll notice there's two columns because one of them is the arithmetic section and one of them is the geometric section. So I'm going to go ahead and actually go to a full screen like this so you can kind of check them. And if you need me to zoom in at some point, I will gladly do that. I will already tell you that down here, like number 44, I'll talk about that one in a second. Once you've checked these off. Okay, there are some problems here. I will tell you how to do them using either Desmos or your graphing calculator. So we'll do that in a second. La 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 la. Garbage. What? That's garbage. Garbage. Doop. Why is that video? Don't care. Do. Wow, wow, wow. That. There we go. Okay. Sign into this. Click this. La la la. Sign in. Go on, Power School. Ciao. La 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 la. Okay. So we have here. He's test ACT. Here, ACT, here, ACT, here, and ACT. Submit, and submit. Perfect. Submit. Overall, are we doing pretty good on these? Hopefully. I'm going to just scroll up to about right there. Yes, no, maybe, who knows? I don't know. Mr. Snyder, I skipped them. I didn't do them because you don't check homework. All the above. Okay. So what questions do you have? I mean, I told you we're going to look at 44 and then 48, I think, is the other one that would go right with that. And then on the other page, I think it's like number, I'm not sure which number it is. It's like that. 28, maybe? I don't know what it is. There's something over there that's the same kind of a problem, I think. So talk to me, guys. Come on. Let me help you if you need it. Yo, Hamza! Hey, let's do one of those right now. Okay, so let me write down what 42 has in the book. La 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 la. Okay, 42 is 1 to 18. 1 to 18. 14 minus 6i. Okay. So this right here is the Greek letter sigma. Okay. And this, the way this is written, can be referred to as either summation or sigma notation. Okay, it's either called summation notation or sigma notation. Now, what does it mean? Well, sigma is like the Greek letter for S. So this stands for sum. What this is asking me to do is to find the sum of this rule as I goes from 1 to 18. That's what this is saying to me. So really what I would have to do is if I was going to do this, this would be the same as finding, is this arithmetic or geometric? What is this? Is this arithmetic or is this a geometric rule right here? Is that linear or exponential looking? Looks kind of linear, doesn't it? Okay. This would be the same. This right here would be the same as this. Find the 18th partial sum. Find the sum of the first 18 terms of this. All right. So you could, if you wanted, you could have done this by finding the first term, the last term, and then use that other rule instead. What's nice about this is you don't always want to find the sum of all terms. Okay? Maybe you only want to find the sum of like terms 7 through 18. If you're going to find terms 7 through 18, you won't use this rule here. So let me show you what this is going to do. So we're going to take this, and we're going to do this two ways. You can either do it on a graphing calculator, or you can do it on Desmos. All right? So here we go. I'm going to start with the graphing calculator. For those that have a graphing calculator, here it is. Okay? You will notice that I already have something like that up on my graphing calculator. But let's clear that out. So what I need to do is I need to find this sigma. Okay? The easiest way to find it is to hit the alpha button and the window button, the function 2, the second function button. And number 2 says summation, and you will see it has a sigma right here. As soon as I hit the number 2, I get this screen. So literally what I do now is I type this in here. Now the only difference is I cannot use the letter I on a graphing calculator. I have to use the variable x. It doesn't matter what the variable is, it's a variable. Okay? So I'm going to say x is going to go from 1. You'll notice it's got a little right arrow, so I hit the right arrow, to 18. Kick over. And then I'm going to type 14 minus 6i. But I'm not going to put I, I'm going to put x, because this variable and this variable have to relate. They have to be the same. And now all I have to do is hit enter, and boom, it will give me the answer. So literally, if I were to go ahead and find the first 18 terms of the series 14 minus 6i and added those up, it would be -774. Okay? I'm just going to do the second one. Okay, again, you could do that using the rule. The second one that I gave you was, let me pull this book over here. We'll do it again. So I'm going to go alpha, window, the number 2, okay, x. So on the second problem I gave you, it was 3. Okay, it goes from 3 to 9. So it's not the 9th partial sum because I'm not using the first and second term. So therefore I can't use this rule as easily. So I'm just going to go ahead and type in the rule here for this one. So I'll go ahead and type it in. It was 72 minus 6x. So 72 minus 6x. Hit enter, and boom, there's the answer. So it's a really nice way of doing a summation. Okay, the calculator basically does it for you. Now I said you can do this on Desmos as well. So let's do it on Desmos. I'm going to close this. And Desmos, boop, you can already see it's there. So here we go. All right, let's say you want to do it on Desmos. So I'm going to do it in the graphing one. So you have to use the keyboard on Desmos, the pull-up keyboard right here. And you're going to go over to Functions, and you go to Miscellaneous. And the bottom center is the sigma button. And as soon as I click it, it gives me this notation. Notice it doesn't use I, it uses N. more like a sub n, like in a sequence like we usually use. So let's do the second problem, or the first problem, doesn't matter what I'm trying to do. If I do the second one, it was going from 3, tab, 9, go out. Now you put the rule in parentheses again. Boop, boop. And that problem was 72 minus 6i, but it's going to be 6n, and there's the answer, 252. So literally, it is doing the same thing that S sub is doing. It just allows you to do any terms you want, not from the first to that, it's any ones you want to use. All right? Is that okay, Hamza?
Yeah.
Perfect. So now you can do that on either Desmos or the graphing calculatrice. All right, anything else over here you want to talk about? Any of these? New? All right, perfect. You guys are my accelerated class, I guess. My other class had questions, more questions. So let's see what we're gonna do today. Here we go. Whoop. By the way, Yusef, you there? I don't know, I can't hear you anyways. If you're there, Yusef, I posted today's worksheet online. Please find it. And I'm going to tell you what each section looks like on this. Oh man, you're tired.
Thank you.
You're welcome. How's Elliot doing?
Good. I think.
You don't know?
Well, I haven't
I think
seen
you should
it.
just go over there and take Elliot and bring Elliot here.
Yeah.
I'd love that. Okay, so let's look at this. First 12 problems. It says, identifying sequences. Tell whether each sequence is arithmetic, geometric, or neither. So it's potentially that some of these are not arithmetic and they're not geometric. They're in neither. The second thing you're going to do is supply the missing terms of each sequence. You'll notice that there are blank spots. You are to do that if it's arithmetic, geometric. If it's a neither, I also want you to try to fill in the blanks because there is a pattern that exists. It's just not an arithmetic or geometric pattern. The third thing you only do if it's arithmetic or geometric, give the common difference or common ratio and write a rule for the nth term. If it's a neither, you're not doing that. All right, on the bottom, it says write a rule for the sequence, then find the specified term. So 13 through 18, it might be arithmetic, it might be geometric. You need to figure it out, write a rule, use it to find the indicated term. Okay? On the back of that first page, 19 through 21, those are arithmetic. That information is from an arithmetic sequence. Write a rule to find the specified term's value. So this is kind of like if I don't give you the first term and I want you to write a rule. Okay? 22 and 23, I've given you, okay, terms of a sequence. I've given you the first three, ... and then some last term. Your job is to figure out how many terms are in the sequence. We haven't done that, but I know you can. 24 to 26, those are geometric. Write a rule and find the indicated term's value. So those are guaranteed geometric. Then 27 through 30, I'm asking you to find a partial sum of one of the problems above. So like number 27, you'll go back to number 19 and find the 20th partial sum. On number 28, you'll go back to number 20 and find the 24th partial sum. On number 29, you will go ahead and go back up to number 25 and find the 10th partial sum. And on number 30, you'll go back to number 26 and find the 14th partial sum. So those last four problems are referring to problems above. After that, it's word problems, okay? Now what we'll do is probably in about a half hour to 40 minutes, we will do 2 practice word problems, not these. I've got 2 different ones. We will do them on the board, read through them, and just talk about how you do these arithmetic geometric sequence series word problems. All right? If you have a question along the way, you can ask. You're more than welcome to. I'll help you out. You can compare with each other and see if you're getting the same things. That's fine as well. I have no problem. All righty? And that is it. That's all I have to say right now. Booyah, booyah. Booyah. I'm going to mute. Actually, I'll mute that. right, so right now I'm just going to ask you to kind of pause where you are, whatever problem you're on, and we're going to do 2 examples of word problems that involve sequences and series. Okay, so I'm going to, let's see here. Where's it at? I think it's, here we go. Let me hit the lights here.
Oh, nothing.
You got it, Maureen? Thank you. All right, so here we go. So this is the first question. Mr. Sullivan and his daughters are stacking firewood in the yard. He just cut down a huge tree, he's stacking up some firewood. The base layer on the ground has 84 pieces. He tells his daughters that each new row of wood should have 4 less than the previous row. And when the girls finish, there are 8 total rows stacked up. Okay? So my 2 questions are, how many pieces are in the top row? And then, how many total pieces of firewood does Mr. Sullivan have? So the first thing I want to do is actually say, is this arithmetic or geometric? So everyone needs to decide which one is it, and then why would you tell me that if you were telling me? I heard somebody already say what they thought it was. Savannah, what do you think?
Arithmetic.
Why do you think it's arithmetic?
Oh, it sounds like it's subtracting.
Beautiful. So that would be the what then? If it's arithmetic, we call that the common difference. Great. Okay. So yeah, this is going to be an arithmetic, and this 4 less than the previous, this is telling me that D is -4. So that means I should be able to write my rule real quick. My rule then for any row would be A sub n equals first term, which is going to be what? 84 plus n minus 1 times the -4. I can just leave it like that. I don't have to do anything with it. I can just leave it alone. Now I want to find out how many pieces are in the top row. So what term am I actually finding then? The 8th term. So n is 8. That's what I'm finding here now. So that's 84 plus 8 minus 1 times -4. That is going to be 84. This is going to give me what? Minus 28. Yep. So what am I going to get? 84 minus 30 would be 54. Add 2 to that. 56. Okay, now, we good so far? Now, why would I want that? Because if I want to find the sum in an arithmetic, I need the first and the last. So that's why I want that information for this problem here. So if I'm trying to find the total now, I'm finding the sum of all 8 terms. Okay, so how did we do this? I'm just going to, these are the numbers that are, this is always going to look like this. What goes here? It's the number of terms you're finding, right? So this is going to be what? 8. This right here inside, we're finding the average of the first and last term. So what am I going to do? The first term is 84, and the last term is the 56. So this is going to give me 8 times 84 and 56 is 140 over 2, also known as 70. So it's 8 times 70, which is 560 pieces of wood then. Okay? So that's an example of an arithmetic sequence / series. Okay? Something that could happen. We okay with this one? Any questions? Okay? If we can do arithmetic, we can also do geometric. Let's look at a geometric one. Here we go. Let me go to a full screen on this one. All right, Mr. Snyder is walking through Town and Country Mall. He hands a nickel to the first kid he sees. The second kid he sees, he gives 2 nickels. Third kid, 4 nickels. Mr. Snyder continues handing out nickels to the kids he sees, following this pattern for the remainder of the day. 1, how much money did the 20th kid receive from Mr. Snyder? And 2, if Mr. Snyder handed out nickels to a total of 38 kids, how much money did he give away in total? Arithmetic, geometric. Well, you probably already know what it's going to be. Just because we did an arithmetic one, this is going to be. How do we know it's geometric, though? It's times 2. It's doubling, right? 1 times 2 is 2 times 2 is 4. So the common ratio on this one is 2. So the rule, this pattern that's generating here, the rule is what? Hold it. What's the first term? 1 times 2 to the n minus 1. Okay. Got that? Good. Let's find out how much money the 20th kid. Now, I'm going to stop for a second. We can do this. But I want you to look at the questions I'm going to ask you for. I'm asking you for how much money. I'm not asking you for how many nickels he got. Isn't this calculating the number of nickels? Is that what I want? I mean, I could do it that way, but maybe it'd be a better way of doing it. Maybe instead of making this a 1, I should make it a nickel is 5 cents, and how do we write that? 0.05. So we're going to tweak this. We're actually going to make it in terms of money, not nickels. And we're going to make this a sub n equals 0.05 times 2 to the n minus 1. Now everything will be in terms of money, which is what I want anyways down here. Okay, 20th kid, here we go. So I'm finding a sub, let's just plug it in, 0.05 times 2 to the, so now you're going to want a calculator, Desmos, something, so you can give me an answer for this. How much money did the 20th kid get? Who's got this already? Yeah, he banked, didn't he? Wait, what's that again, Lane? 26,000? You guys agree with that? Do I have confirmation for that answer?
Yes.
Now remember, we said that geometric is like what type of function? Exponential. And what happens? Exponential functions, they're really slow growing, and all of a sudden they do what? They shoot up, right? So that's why that number gets really big. It starts small, goes 5 cents, 10 cents, 20 cents, 40, and then all of a sudden it just starts to ratchet it up quickly. That's what's happening here. Now I got to find out how much I have to borrow so I can take care of what I have to pay out. So now I've got 38. Okay, so now I'm finding the sum of 38. So if I'm doing the sum of 38, now I'm using the summation. So what goes here? Is it a 38 or is it the first term if I'm doing a series for geometric? It's the first term. So what goes here is 0.05 times, on the top it's going to be 1 minus what?
38.
Not 38. Is it? 1 minus r to the 38. So it's going to be 1 minus what? 2 to the 38 over 1 minus 2. Now it's just crunching the numbers for this. Again, this is a calculator problem once I've written it down. I don't expect you to do this by hand, in other words. How much total do I have to tell my wife I spent at Town and Country when I get home? Oh yeah, a lot. It might be better for me to just borrow somebody's calculator once they have an answer. Donovan, Inkman, you got an answer?
No.
You do too? Isn't this your answer?
No.
Oh, it's not your answer. I mean, okay, I've got an answer. You guys tell me. Probably going to give it to you in scientific notation. Does it start with a 1?
Yes.
Point.
37.
That's the 1. Okay, so this is what you get in scientific notation. 1.37 43895 35, and then you get this on your calculator. That E10 means what? Times 10 to the 10th power. So that means the decimal gets kicked 10 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have to add a 0. So it's 1, 3, 7, 4, 3, 8, 9, 5, 3, 5, 0. Boop, boop, boop. How much did I give away? 13 million dollars, half of last year's salary. It's okay. There you go. What's that?
That's not millions.
Billions. Billions, yeah.
That sounds like
Half of last year's salary, like I said. Chunk change, man. That's why I can do that all the time. Climb it, town country. People last year. All right. Okay, they don't mind. Neither do the parents.
It's like that thing where they said that you put a penny in a jar and then you double it every
Yes.
day, you'll end up with $1 million.
Yeah, if you guys were, when you were little, if you start saving, it's crazy how much money you can save. If you just use a little exponential logic. All right. So tonight, your job is going to be to finish the worksheets. If you don't get them finished tonight, you can finish them tomorrow. Tomorrow, I will post the answer keys. You can check them. Thursday, you'll have questions ready if you have any. And then on Thursday after that, we will go ahead and take a quick quiz. Once we've done that, we will see what we need to work on, and then I'll just adjust with it right then, okay? So we're going to I'm not quite sure what we'll do after that on Thursday, but we'll kind of play it by ear what we're going to do on Thursday then, all right? All right, that's it. That's all I got for you guys. Yusef, if you have any questions, I'm here for you.
Oh, can you check this?
Oops, hold on a second. Annie, you can come up here.
Oh, okay. That's positive.
That's how the numbers are weird.
Yep.
It can be. Plus 2 minus 4.
Oh, I know what happened here. Why'd you put a 1 here?
That's a really good question.
Because you put 5, because that's 5 plus. This should be something plus this.
Oh, I didn't put
And it's-
plus, but I know you're adding.
Now, did you go back and actually find the first term?
Yeah.
You did? Okay, you can do that. This should be plus sign. Maybe that's why you don't have it right. You need to add to that, I think. Well,
The plus sign?
yeah, it should be 1 plus n minus 1 times -3.
Yeah, I know. I just didn't write it on accident.
So then you would get -3n plus what, 5?
No, because it's 3 times 3, and then plus that is 4.
Oh, so you actually got lucky and
I
got it
just
right
didn't.
here?
Yeah, I
Okay.
didn't write it.
So then you did -3 times,
And then I put 21 in there, which was 60. Oh, wait. Yeah, 63. -63 plus 4.
something's not right here. I don't know if that's 1 or not. Is that really 1? Let me see here. That's not 1.
That's not 1.
No, it's 2.
So how do you go back and find the first one?
Because what you should do is use these and make it a sub n equals -19 plus n minus, you use this value of n instead,
And
then times the -3. So what happens is you get a positive 21 and a -19 is a positive 2. So you get -3n plus 2. That's why.
wait, -3 and plus 2?
Yeah, because this gives you plus 21. And a 21 minus 19 is plus 2.
That's 19.
Yeah, sorry. Yep.
So then it should, so then I use that to plug
Yeah.
it in to find it?
Yes, correct. This one's right.
Oh, okay, thank you.
Yep.
I just want to make sure I did this right. Like after just making sure I understood what you're thinking. So since this
That's right. What do you have there?
5 and
Yep.
okay.
That's it. You got her. Got her, Otter. Swim back to your desk.
I just wanted to make sure that these are right before I continue.
I can do that. Okay, let's
The
see.
ones I don't know how to do.
Are you talking about all of these or just anything in particular?
All of them.
Let's see. Blah. That's good. Good. I guess my glasses are better off here. 21, 25. No, you're fine. Don't worry about it. That's good. That's good. That's good. 0 and 16. Good. Boom, boom, boom. Okay, now this actually, okay, so it's not arithmetic, right? Because you add 4 and then you add this. But what's the other option?
Oh, you're multiplying by 5.
Yes, it's geometric. Okay. Yeah. So this one you can fix. This one. That's good. This one is good. This one, good. This one is good. This is a neither. That's right. I'll just tell you that's a neither. This is good. That's good. And that's good. So yeah, so this is the only one you just got to go back and fix. I mean, and these numbers you actually have are right. Just that it's not a neither, it's a geometric. And then this one, see if you can figure it out, okay? And then here, that's good, and that's good. And this is not. So what did you do? You did a sub n equals 10 plus n minus 1 times negative 5.
Maybe we're wrong.
Well, let's see here. What did you, I wonder what you put in. You put 11. Oh, what's 11 minus 1?
Oh, 10. Oh.
And times
Yeah.
negative 5 is negative 50, goon
Probably
face.
didn't.
Come on, you know what you did? It's almost like you took 10 and this and made it like, I think you almost made it less like a positive 5 somehow and then just added. So you just made some gypsy mistake there. So, you know, that happens sometimes.
Is it negative 61?
Wait, what are you asking me? What number?
20. Is it negative 61?
Yeah, that's right. Yeah.
And my dad is obsessed with firewood. He's obsessed. We need more firewood. I'm like, no. Okay, 20 feet.
I'm on
20 rows.
Stop sharing. Stop YouTubing. Oops. I don't want to do that. Stop that. Stoppy.